happy to introduce my next guest, who is Goldman, CEO and co-founder of Biotic Circular, and somebody that was a delegate last year. He was running for the airport at the end of day 2, and he basically said, Paul, I love this, I'll come back as a sponsor. So thank you, Adi.
Hi, so thanks for staying to hear me. I'm always getting the difficult times. Next year, I want to be in the morning. So I'm one of the 2 co-founders of Biotic. We are based in Israel, and I'm not going to lecture you how bad plastic is, but I'm sure you're aware of. But what I want to just describe here in 10 minutes is how we look at sustainability, or how we look at solution for the future to come. So we are a company that produce, at the end of the line, we do a PHA that is called PHBV. I'll explain why is it important, but what's more important for me is to show you how we plan to have our product at the same price, or at least similar enough price to fossil-based plastics. So we started the company by going into the ocean. We realized that if we want to achieve something, we cannot use just agriculture product. We just don't have enough now to support like 10, 20, 30, 40 years ahead of materials as biomass to replace plastics. Saying that is that we can also use any type of sugar coming from agriculture, but we wanted to find a more sustainable way forward. So we are using algae or seaweeds that are available all over the world. The idea is that it also enables localization. So wherever we go, there is probably a type of seaweed that we can use. It's either an ocean-based seaweed, it could be a lake-based seaweed, it could be growing on rivers. We can use any type of a plant that comes out of the ocean. We are doing a process on it to extract the carbohydrates. The reason we are extracting the carbohydrates is because most of these plants has other valuable products, such as proteins, pigments, fatty acids, vitamins, iodines, things that can serve other industries. The idea here is to use as much as possible what the biomass offers. So depending on the type of material, we can extract different types of byproducts that can serve other industries. Then the carbohydrates that we extract are fed into a fermentation process. The fermentation is done in seawater. It's an open fermentation, non-sterile and continuous. Again, reducing cost, energy, reducing cost of maintenance. And then the microorganisms that we have inside the fermentation digest the carbohydrates, and they produce in their cell, they produce a polymer that is called PHBV. PHBV is actually a copolymer, so it is comprised of 2 units, hydroxybutyrate and hydroxyvalerate, for those of you who knows. And the ratio between these 2 units basically sets, amongst other, also the mechanical properties of the polymer. So a low ratio will mean a rigid product to be made of, and a more higher ratio, so more valerate into the polymer, means more and more flexible. So with one application that we can control the microorganism through metabolic engineering and process engineering, we can basically output the vast majority of what plastic producer needs. Anything from auto parts to garden furniture, electronics, supermarket bags, packaging, and fibers, all together. The advantage of this product is that it fully biodegrades in heavy microbial environment. To be more specific on that, the ocean, for example, the product will biodegrade within 28 days if by any chance or accident it reaches the ocean. Same goes for soil. So if somebody throw it in the park, it will biodegrade within a month. When it biodegrades back into CO2 and water, so there are no hazardous material, no harmful, no microplastics. There's nothing basically that harm anybody. It's also edible. I wouldn't advise you at this stage to eat it because it's not that tasty. But if you do, nothing will happen to you or to an animal for that matter. So it will just generate some gases maybe, but not more than that. And what we wanted to achieve when we started the company are basically these 3 main elements. So biodegradation comes from what we've selected to build. So the polymer itself is already biodegradable, and we've done the testing to show that. Secondly is to fit existing production line. So it is a thermoplast. So it can go, and we've done it through spinning, extrusion, injection, press molding, cast extrusion. So this is done. The temperature range and the time of operation, window of operation is very similar to what you know, PP, PE, and PET. So there is no big change that a company needs to do. So no increase in the manufacturing cost. And lastly, which is probably, if you are a corporate, it's what interests you the most, is the cost parity. And the way we are going to achieve that, some of it I already mentioned. So we are using seawater. Seawater are much more cheaper than using treated water or distilled water, which most of the industry is using. Secondly, it's a continuous process and non-sterile, so we don't need to stop it. There are no there is no downtime, and basically it's non-sterile, so we don't need to sterile it. There is no need to have a steam room or something, a clean room, in order to make that reworking again. Lastly, in order to reduce also the CAPEX, because machinery is heavy on building an industrial facility, we have designed our own vessel. The design of the vessel comes from, one, the fact that we're using saline water, so it's very abrasive, and anything bioreactors doesn't survive that long. So we designed it in a way that it will stay as long as needed. Secondly, it has no moving parts inside, so there is no need to maintain it or stop it or repair parts. And we have one engine that is outside, and he's doing everything that the fermentation is needing, whether it's aeration, steering, heating, everything is done with one engine, and that's to reduce the CAPEX needed. We are at the point where that we are about 5% of what a bioreactor costs in the industry. So it's substantial decrease. Alongside all the other elements that I've mentioned before, that brings us to the point where we target to reach fossil-based parity when we're industrial. Most of the people are talking about packaging and single-use plastics, so we are doing that as well, but we are also doing projects with auto parts manufacturers, textiles, home compliance, so things that are a little bit far away, cosmetics, because there is a great value in the polymer that we bring. It can just do a lot of things, and the byproducts can also serve as a circular economy. So we can take from InBev, for example, the beer manufacturer, the leftovers that they have, and generate them the plastic that they need for the labeling or the bottling or the crates. So most of these companies have circularity effect on what we do. So it's a lot of not just what is in it for me, but also what is in it for them, and how this all become the big picture. We have a very small facility, so we are at the pilot stage currently. We have a few vessels of 1,000 liter, altogether about 3,000 liter fermentation. So we've shown proof the technology. We made tests, mechanical properties on the product themselves with the companies and customers, and we are just hopefully in August, we're going to move to a demo facility also in Israel for the time being, in order to scale up and achieve inline testing. That's our goal. We are not going to go to industrial scales before we have customers' approval. And we've done that since the time we had milligrams in our hands. We always send it to customers, get the thumbs up. Once they got the thumbs up, we move to the next stage. So we are currently waiting for the thumbs up on the mechanical properties, environmental testing that are done by our colleagues, and when that is ready, we are already ready for the next scale up, which will be product evaluation. And the idea is that when we reach to the final stage of the demo, we already have some sort of an offtake agreement, commercial agreement, LOI, MOU, whatever it is. So we're not just coming to the market and expecting somebody to use the product without having any testing of it before and doesn't know what it does and spend a lot of money. So that's our approach. We are backed by VCs that are has sustainability tickets behind them, or impact VCs. We've been part of a lot of accelerators and programs in the past and today. We're part of the FoodTech 500. And if any more information, we are starting an A round, so if you also want to invest, it's a good time. Thank you so much. It was a pleasure being here. Thanks, Paul.